So before we dive into the late knee extension and femoral rotation concepts, we need to understand the role of biarticular muscles and how our running cycle is really controlled by all the sensors in our body first. So the biarticular muscles span two joints and are the rectus femoris, the hamstring muscle group, and the gastrocnemius in the lower body. So the special thing about them is their muscle architecture, and that also dictates their function. So they have the most pinnate structure in the lower body, and pinnate structure means it's kind of like a feather. They're organized like in a feather, and that does two things really. So the first thing is, because they're organized in a feather like this, their muscle fibers are shorter. So it's really less real estate that needs to shorten when they want to shorten. And that leads to higher contraction speeds and faster relaxation times, which is really important. The second thing it does is, because of this pinnate organization and this tight kind of organization of the muscle fibers, you simply have a higher density of muscle fibers in less space. So this leads to just higher forcefulness in those quick contractions. So that means a pinnate muscle structure biases muscles towards a quick, forceful, really elastic muscle action, which makes them built for speed. So Franz Bosch, where these images are from, says that pinnate muscles are really built for isometric muscle actions and stretch shortening cycle actions, which kind of is true. In terms of the isometric muscle contractions, we'll get to that later. Now, their structure dictates their function. Now, because they are biarticular and they span two joints, that means they are kind of interrelated. Especially the hamstrings and the rectus femoris are really antagonists to each other. So the hamstrings not only bend the knee but also extend the hip, because they originate here at the ischial tuberosity, which is the sit bone, which is going to be important later on. So remember the ischial tuberosity, the sit bone. Second thing is the rectus femoris. They extend the knee, and here proximally they flex the hip. Okay, so this directly the counter guy to the hamstrings, which extend the knee here. And third, we got the gastrocnemius, which bends the knee and obviously extends the ankle. So because they are interrelated like this, and because they essentially respond to each other, they are built to transmit force down the chain. So let's start with the hamstrings here. So the arrows, the white arrows that you see here is the direction in which they are transmitting the force. So the hamstrings will slow down knee extension, and because they bend the knee, right? So because they slow down knee extension and extend the hip, they will transmit the force towards that hip extension. Now the rectus femoris, because it flexes the hip, will slow down that hip extension as it moves towards the fully extended position and turn that hip extension moment into a knee extension moment. And the gastrocnemius, because it bends the knee, will slow down that knee extension so that you just don't overshoot the knee. Like if you don't want to be hyperextending your knee, right? So because it slows down knee extension, it will turn that knee extension into ankle extension. Now, if we look at this picture on the right here, so you see this is the kind of the vertical ground reaction force that passes through our body when our foot hits the ground and the foot is in front of the hip. So this poses a great big moment arm for the glutes to get that femur to extend. However, this force that passes through here automatically wants to make the knee extend right away. See these arrows? It kind of like, just by the nature of the position of the joint, it will want to make the knee extend back. So we need muscles to keep the knee in place or even bend it more. So you see here, the goal is to get the leg retracted here. So the gastrocnemius, which inserts and originates here, will try to keep the knee bent. And the hamstrings also will do the same thing. They will try to keep the knee bent. So we have really two muscles that are attempting to shorten in order to bend the knee even more and to keep it bent so that our glutes can perform the thrust that we need them to do. And that leads us directly to the next point, which is the biomechanics of the hamstrings. So you can pause the video right here and read this little text here. So this is still from the book Running from Franz Bosch. And really what he's saying is that the hamstrings mainly work isometrically when the foot is on the ground, and their thrusting action is performed in the air, because when your femur is flexed up to 90 degrees here, you have the largest moment arm for the hamstrings to perform hip extension. And once the femur is down here, the moment arm is really small, so they don't really, so he's saying they can't work optimally when the foot is on the ground because the moment arm is just not big enough for it to perform some hip extension. So he's saying, therefore, the hamstrings work purely isometrically when they are on the ground. And I believe that is wrong. I believe if your intention is that your hamstrings are passive and just kind of working isometrically and holding something in place, you will not have that delayed knee extension, that femur rotation, and that thrust of the glute. Because I have done this. I have trained myself to run like this. I thought that all the work is performed in the air, and on the ground you're kind of just passive and rolling over the foot. And that is just not the right way to go about things. Because if your hamstrings and also your gastrocnemius and the rectus femoris, but especially the hamstrings, if they are passive, they will not keep the knee bent or keep it in place so that your glute can perform the work. They need to attempt to shorten, because you have only these two endpoints, and if they stay isometric, nothing will really happen, and you kind of want the knee to bend a little bit when you hit the ground. So you will need them to try to shorten to keep the knee in place, and so that your glute can perform the work. So Franz Bosch says the hamstrings cannot work properly when the foot is on the ground because the moment arm is small. I say that's irrelevant. I say that is the exact reason why the hamstrings need to try and compress. They aren't trying to extend your hip. They aren't trying to help you with that thrust of the glute. They are just trying to retract the femur. They just want the femur to go back so that your glute can actually do the thrusting, which has a great moment arm here because it spans all the way here and it starts here. So the hamstrings need to try to shorten, and they are very much active when the foot is on the ground, trying to compress. And the same thing for the gastrocnemius. This is why I believe the isometric theory is kind of wrong. If you want your femur to go from here to here, you need your hamstrings to try to shorten.